This one looks innocent enough with x squared minus natural log of xy plus y squared. In order to find the derivative of this, one thing I noticed is we have this product inside of a natural log. So this term in particular is going to be fairly difficult. We could do a little algebra maybe to rearrange this before we even get started. What I'll do is I'll just add that natural log to the other side. So on the left-hand side, all we'll have is the x squared plus y squared. But then on the right-hand side, we'll have natural log of xy. And this gets rid of a bunch of negatives, kind of cleans things up a little bit, or at least separates them. Anyway, to find the derivative, we have to first find the differential. X squared is going to turn into 2x dx, and y squared is going to turn into 2y dy. And it's this right-hand side that we really have to worry about. First of all, we have a chain rule happening. Because that xy is inside of the natural log, we're going to take the derivative of natural log, which is 1 over, in this case, xy, and multiply that by the derivative of the inside. The thing about the derivative of the inside is that that's a product, so we have to use the product rule, and that will be 1 d2 plus 2 d1. From here on out, it's really just a matter of algebra or organizing things real well. First thing I'll do is take this fraction and distribute it inside of the parentheses. So I'll leave the entire left-hand side alone. Now, when we distribute this fraction inside to the first term, we'll have x over xy dy. And when we distribute it to the next term, we'll have y over xy dx. Obviously, these things are going to simplify a little bit because the x's will cancel and the y's will cancel in this term. And now what I'm going to do is rearrange things so that I get all the dy's on one side. So I'm going to subtract off this 1 over y dy. That'll get this entire term off of the right side and bring it over to here. Then I'll also subtract 2x dx to get rid of this term on the left. So I subtract 2x dx over here. What this does, it leaves us with only dy terms on the left and only dx terms on the right. Those two dy terms, when I factor out the dy, is going to be 2y minus 1 over y dy is equal to 1 over x minus 2x dx, when I factor out that dx. We can simplify these two fractions by getting common denominators, multiplying by y over y here, and taking this one, multiplying it by x over x. So we'll have 2y squared minus 1 over y dy. And on the right-hand side, we'll have 1 minus 2x squared over x dx. And to finish it up, we're going to divide. I want dy dx, so I have to divide by dx to get these ones to cancel, which means I'm going to have to get rid of this term on the left. Remember, dividing by a fraction is the same as multiplying by its reciprocal, by y over 2y squared minus 1. I know it looks like a mess for a second here, but we have our solution as being dy dx is equal to the product of these two fractions, this one and this one. When I multiply the numerators, we have y times 1 minus 2x squared over x times 2y squared minus 1.